Okay, so for this one, we are trying to simplify, and what makes this not simplified is that we have a radical in the denominator. And anytime we run into that, we have to use some technique. We'll see a couple of them in this chapter on how to take care of those. For this one, we're going to use the property earlier when we were simplifying the section. Remember, we had the one that if we had a times b, if it was convenient, I could think of it this way. Likewise, if I have something like this, I could think of it as that. This is the one that goes with that, which is division. So if I have the root of a over b under a single root, then I can think of that as the root of a over the root of b, or vice versa. So depending on what we're doing with it, sometimes this form is convenient and sometimes that form is convenient. Right now we're in this form, and so what I'm going to do is I'm going to rewrite this as a single root. And what that will do is make it a little more clear that now I can reduce that fraction. And so if I do that, let me go ahead and erase this stuff right here so I don't harm myself out of it. Then 8 over 2, that makes 4 and root x. And then remember from earlier in the section, if there's any sort of perfect square going on underneath the radical, we need to simplify it. So square root of 4 I can simplify, and then that would become 2 root x. And then this will work on more complicated things too. You know, say I have the square root of 50 x to the 10th y to the 7th over the square root of 2 x to the 4th y to the 5th. So that looks horrible like that, and this is going to be like probably the next problem coming up. I think will be more like this one, where it's got a little bit more going on. So let me just show that here. And so all I'm doing is rewriting that all under a single radical, and I don't even have to do that step if I don't want, but just to kind of show I'm just going to reduce fractions here, but I could have done it from there if I preferred. So here, this is going to give me 50 over 2 is going to be 25. If I have 10 x's up and 4 x's down, if I think of canceling out 4 of those x's, I would still have 6 left in the numerator. So think of 10 x's written out and 4 x's, and then canceling out 4, you would still have 6 left. Likewise, if I had 7 of these and then 5 of these and I cancel out all 5, I would still have 2 in the numerator. So now, instead of that giant mess, I have a much smaller mess, and if I simplify where I can, which would be all of it, square root of 25 would be a 5. Square root of x to the 6th, remember that's our thing where we think of this as a little invisible 2. So 2 goes into 6 3 times, so 3 come out because I have 3 pair, and then 2 goes into 2 once. And it's just saying the square root of y squared would be y. So we started from that big old mess and then got it down to here. So when that works, when you're able to reduce like that, that's a great way to take care of the radical in the denominator. I suspect the next video I make will be when that doesn't work, so we'll see.